Hello everyone, my name is Jay Padamiti, and in this video, I'll be talking about what's new with credentials in Power Automate. Let's get started. As part of the agenda, I'll go through the overview of credentials in Power Automate. In my previous video, I have shared details about credentials in Power Automate, but there are some additional changes, exciting new capabilities that were introduced in the recent months, so we will be covering those. As part of the credential stores, I will go around the Azure Key Vault and CyberArk as the two choices for credential stores. And I will also walk through on how you can actually do certificate-based authentication in Power Automate for desktop, followed by a quick demo. Let's get started. Let's go into a quick overview of credentials in Power Automate as a refresher. In Power Automate for desktop, credentials are leveraged for two different scenarios. One is to actually manage the bots or machines through what we call as the desktop flow connection. So imagine you have a cloud flow that you want using to invoke a desktop flow. For that desktop flow connection, which needs to run on a machine, you will use a desktop flow connection, right? So for that, now you have introduced credentials that can be used to manage that connection. Similarly, we have introduced credentials for desktop flow connections, desktop flow action. In this action is actually a native action in Power Automate for desktop, where you can use it in your automation workflow, in desktop flow, essentially, to access your system of record or any application-specific logins using the credentials. As a quick refresher, let's talk about credentials in Power Automate for the credential stores, Azure Key Vault, and CyberArk. Let's start with the Azure Key Vault as the credential store. Credential is composed of two things for AKV. One is the username, which is a text environment variable, and the other one is the password or certificate. Previously, before the recent update, password was the only choice, but now we have introduced certificate as the other choice. Both password and certificate are stored in a secret environment variable, which point to the Azure Key Vault. So this is an exciting capability. With certificate, you can enable the certificate-based authentication for managing the bots as well as the machines in Power Automate. Okay, let's see how the CyberArk credential is laid out. CyberArk credential is composed of three things. One is the username with text environment variable and object name, also referring to the CyberArk as the object name. The text environment variable captures the underlying object that actually stores the credential in CyberArk. The final one is a credential store, which is a JSON environment variable composed of server address pointing to the CCP or the central credential provider URL, the application ID from Password Vault Web Access, the safe, once again, the value from Password Vault Web Access, and also finally the folder name where the credentials are actually stored in CyberArk. So this is in a nutshell how credentials are structured, both for Azure Key Vault and CyberArk. Okay, here is the first scenario we have talked about, the desktop flow connections. Desktop flow connections, both the credential stores, Azure Key Vault, as well as the CyberArk are supported. Here is how you define a desktop flow connection. You provide the connection name, you say connect with username and password, and you select the machine or the machine group. And the new capability as per the credentials, here is where you can select the credentials that you have created to create that connection. And next, for the desktop flow action, only CyberArk specific credential store is supported at this time. So here is where you can provide the CyberArk specific credential as part of the desktop flow action. All right, let's take a quick look at the Azure Key Vault specific credential store and how credentials can be configured using this. You have seen this in my previous video, but there is a new update in the recent months that was introduced where we have, I'll talk about what the new change is, but let's take a look at this overview diagram, if you will. As I have mentioned before, credential is made up of two components, username and the password. Password is nothing but a secret environment variable pointing to a secret value in a Azure Key Vault in your Azure subscription, right? So this is for the scenario that I've just briefly described, the desktop flow connection, right? This is a secret-based desktop flow connection scenario. For this, what you're pointing to or what you're creating is the desktop flow connection with credentials, right? So this is very simple, but like I mentioned before, there is an update. Previously, we have to create a cloud flow to ensure that the any updates or password rotations happening on the secret. We had to manage it outside of this flow. But now, with the latest introduction of the credentials service, that requirement is no longer required. So it is all encapsulated, meaning service takes care of whenever a secret is refreshed on the Azure Key Vault or a password gets rotated on the Azure Key Vault, the service will always retrieve the updated password/secret. Okay, here's the new scenario that was introduced for the desktop flow connection. The new scenario is called the certificate-based credentials. Similar to password, the certificate is also hosted in the Azure Key Vault on your Azure subscription. As you have seen in the initial anatomy of a credential, like I described, the username is once again the text environment variable, but the change here is the certificate now replaces the password as the secret environment variable. Similar to password, certificate also needs to be created in Azure Key Vault with proper access and identity permissions there on the AKV. Yeah, I think this is a very exciting capability that we have introduced to allow for modern authentication capabilities as part of the new cybersecurity requirements. Okay, let's talk about the next credential store that's available for credentials in Power Automate, CyberArk. With CyberArk, the credential is composed of three things: the CyberArk username, the object name, and the credential store, like we just described in the previous slides. Username is a text environment variable, so is the object name. Credential store is a JSON environment variable, which is going to contain the server address, application ID, safe, as well as the folder. Object is actually points to the secret in the CyberArk's credential central credential provider, CCP is the way we call it. So this scenario is very much specific to the desktop flow connection to manage the your either the host machine or the machine or any machine or a VM that actually runs the desktop flow. Going to the desktop flow action scenario, the composition of the credential remains the same. It's just that the object for where the password is stored refers to a second object, pointing to the credentials of the underlying system of record or the application that this automation is looking to integrate with or automate. So this is a great way to fetch the credentials from CyberArk into the desktop flow. Okay, so let's take a quick look at how you can actually create a new credential in Power Automate for CyberArk credential store. Right. So let's type in the credential name as that and paste credential, and then click next. And here's where you'll see CyberArk supports both connection as well as the desktop flow. So you can save, select both for that. And then you can create a new CyberArk store or use a previously created one. Let's say if you want to create a new one, here is where I have described about the CCP-based store. So just type in that, and then you have the host name that you can say CCP host by port. So by no means these are accurate, so feel free to use your own CCP-specific details here. Okay, so by doing this, I'm able to create a new environment variable for that store, and then select the username. Anything that should be available should be able to create that. Just credential username, and then any object name that you want to use as the object name, you can definitely create that environment variable. Or you say a display name as the CyberArk object name, and then you can say whatever the object name that you have selected. So this will go ahead and create the object name as well. Okay, so that you can save this and use this as the credential CyberArk based credential, supporting both desktop flow connections as well as the desktop flow actions. Extending the scenario for CyberArk, now we have introduced a desktop flow connection with machine mapping as a supported capability for CyberArk-based credential stores. The way you see it here is once you create a credential-based mapping within the Power Automate portal, which is basically pointing to the desktop flow connection, right? What it is it serves two mechanisms. One, you can create a mapping for a particular machine or a server in this case that can use any number of credentials for its automation, right? It could be for a machine, or it could be for any of your system of records, or any of those combinations thereof, right? So that could be one mapping, that mapping-based credentials that you can use in that situation. So like it said here, for a server, map the machine with all the session credentials as one mapping. In a similar way, you can also do or create a credential-based mapping or mapping-based credential for a mission group. For each individual machine within a mission group, you can have a dedicated credential that is mapping to an object in the CyberArk CCP's vault/object store, right? So you can create that, and that way you have that mapping defined for a desktop flow connection as well, right? So this is a brand new capability that we have introduced, and very excited to see how you can actually leverage this. Okay, we have come to the final section of the video, which is the certificate-based authentication, CBA. I'll provide a quick walkthrough of this capability, and then we'll do a quick demo. Okay, here is a basic checklist to enable CBA for Power Automate for Desktop. All of this information is available online, but what I've done here is I have consolidated it as a easy-to-use checklist that helped me to do this demo. So I'm hoping that it is also helpful for you. So the first step that was defined there was to set up Microsoft Entra CBA for tenants. It was broken down into 4 major steps followed by testing. First one is configuring the certificate authorities with PKI-based trust score, as well as the second step was to enable CBA on the tenant. Third one is configuring authentication binding policy, followed by username binding policy. What I would like to point out is for public key infrastructure, I would suggest you to take a look at this link, which is aka.ms/securing PKI, to ensure that you're following the guidelines as well as the best practices to ensure that PKI is secure in your organization, right? And I also want to point out that from now on, whatever I'm describing is created as a reference/test implementation, as I have done this purely for illustration purposes, right? So that's why I may have used some simple measures, which probably are going to differ from your organization implementation. So feel free to use it as a test implementation only. One of the prerequisites before we enable CBA on the Microsoft Entra tenant is to create a root cert. Since I'm starting with a fresh tenant, I don't have a root cert CA certificate. So I went ahead and downloaded OpenSSL and used it to create my root certificate, right? Here is the first step that I have used, generated a private key using this command with a 256 hash algorithm. And then followed by that, once my key is generated, I named my key as the myEAI.key. I have used that key to create a CSR. CSR takes in, once again, the SHA-256 algorithm there, takes in the key and spits out the CSR file. With that CSR file and my key, I go ahead and create a certificate. So here is the X5019 certificate, and this is the root certificate that I will be importing into my PKI. Right? Similarly, we also need to create a user certificate. This is the user certificate that will be used to log into the machine instead of a password. So I went ahead and followed the similar steps of creating a private key, a CSR, a user certificate with a CA key. As you can see, I have to use my root CA key. This is my public key as well as with my secret. And I export that secret in PFX format as it described in the documentation, and ensure that you export it without any password. Okay, so now that you have completed the prerequisites, let's jump on to the actual steps that are required to configure the CBA on the Microsoft Entra tenant. The first thing is to create a PKI store on the Microsoft Entra in the portal.azure. After you log into the Microsoft Entra Admin Center, you click on the Security Center, and then the Security Center will take you here in under the Manage section. You click on the Public Key Infrastructure. Here's the PKI store that I have created by providing it, right? And then the certificate, the root CA certificate that I have created in the previous step. I was able to add it by doing this. I upload the certificate, and then you say whatever the certificate, I'd say root, and then provide the CRL, and then hit save. So this is how I was able to create this root certificate into this particular PKI store. Okay, the next step is to enable CBA on the tenant. How do you do it? You have to go to the Microsoft Entra Admin Center and create a user group called CBA users. So that way you are enabling this only to a specific group of users. And after that, you enable the CBA at the tenant level, right? So let's quickly go back to see how we can actually do it. Once you're in the Microsoft Entra Admin Center, click on the Security Center, and then click on the under Manage, select the authentication methods. Once you're in there, you will see that there is a CBA, the certificate-based authentication, is listed out here. Once you click on it, it will bring you to this screen where you can say enable it first of all, and then you can go ahead and add the groups, right? So if you want to set it to target to few select groups like we talked about, CBA users, so you create that group. It can be anything. I just named it as CBA users. And once you do that, you click save. Okay, the third step is configuring the authentication binding policy. We go ahead and create the authentication binding rule, followed by the binding policy rule as well. Okay, to configure the binding policy rule, you come to the configure section of the certificate-based authentication settings, and then you click on the rule. Here you provide the certificate issuer, and then multi-factor authentication, select the roots certificate issuer, and then you can choose affinity binding as per your requirement, and then you say add. And that would select that. So I have selected the affinity binding to be high. So once you do that, it will create that binding for that. Similarly, you can do the username binding as well by clicking on the add rule, create the select the low affinity under the subject, and then the certificate user IDs, and then click add. It should pop up the certificate field as the SKI. So with that, we're good to proceed to the next step. Notice that I have selected SKI as the certificate field as the username binding. So the reason why we do this is when the user logs in with a certificate, now it uses the SKI as the identifier to authenticate that particular user, and so on and so forth. Right? So that's beyond the scope of this video. Let's get to the point on how you can actually get that SKI and update within the user. The first thing that you can do is after you import that user certificate that we have created in the PFX format, we can extract the SKI, the subject key identifier value from that certificate, and come back to the user in the Microsoft Entra, and then edit that certificate user ID and provide that in the format of XO X509 with a colon and in the angle braces SKI, and then provide the value of the SKI, the subject key identifier value that we extracted from the certificate. So that is what connects the certificate to the Microsoft Entra. Now let's go ahead and test this configuration. I have my VM all fired up. I am going to provide the username and then see how we can test this configuration of certificate-based authentication login into the virtual machine. Okay, here is my username, and here you see the sign that it is using the certificate to sign in. I have not provided my password. It just took the certificate that I've already installed on this machine to run it. So that's how the CBA is configured on the Microsoft Entra. The next thing is to store these certificates in the Azure Key Vault. You can follow the article on how to import that certificate into the AKV. I'll quickly show you on how that actually looks. Once you're in the Microsoft Azure portal and you are in the Key Vault, click on the Key Vault that you have selected. Under Objects, we select the certificates. Right? Here's the certificate that we have imported in the PFX format. So if you look at this, this is how we have defined it. As you can see, here is the shop footprint and so on and so forth. Okay, once you have imported that PFX certificate into the Azure Key Vault, what we need to do is we need to create the credential in Power Automate. So to create the new credential in Power Automate portal, you come here and then you say AKV cert credential, copy and paste it as part of the description. AKV cert. Okay. Here we are using the connection, desktop flow connection, and then we select the Azure Key Vault as the key store, credential store. And once you do that, it pops up two different types of credential types, right? So here one is the previous password-based authentication, and the new one is the certificate-based authentication. Once you do that, you can either create a new one or select an existing environment variable. So I already have a environment variable that I have used it to create the username, and then the similar way I can create a new one. And this is where you provide your name for the cert name, as well as the Azure subscription ID, the resource group, as well as the Key Vault name, and the certificate that we have just seen on the Azure Key Vault. Once you do that, it becomes it becomes the certificate the way that you create it. Right? Once you save it, the credential gets saved, and you will see that as AKV-based certificate-based credential. Once you have created the credentials in Power Automate, and the final step in this set of configuration is to enable the admin consent for unattended runs. Here's the link that you can follow along to enable the admin consent for unattended runs. I will quickly show you the two steps that are required. One is the enabling the Microsoft Entra Authentication for RDP. There is a remote desktop application name for which we need to enable this. The set of steps that are listed out in the article, let's take a quick look at them. So here's the admin consent for unattended runs using CBA. Requires two steps. We are at the step one of it, which is enabling the Microsoft Entra Authentication for RDP. We need to look for the Microsoft Remote Desktop with the application ID starting with A4A, ending with B9C. What we need to do is we need to open up the Cloud Shell or the PowerShell, and then run this command, which allows to connect to the graph and execute it for against the app ID for MSRD, and then complete the remote desktop protocol enablement. Let's see how that actually looks in the execution. So this is what I have done. I have used the Cloud Shell to connect to my environment on the Azure side. I have done the mggraph command, provided the app ID, and enable the remote desktop protocol for that particular app ID. The next step is to hide the consent prompt dialog for the target device group. This one requires few steps, which are listed out in this article. Let's see how that article looks about. Okay, so this article lists out that you create a dynamic group in the Microsoft Entra ID, add the device that we are trying to run, in this case, the target machine, into that device group. And then the output of that should look like this. Once you have the device group, you enable the security configuration for that, for the, once again, the MSRD ID for that device target group. Okay, so that completes the configuration of all the things that we need to do to enable CBA. Now let's see how it all plays out with a quick demo of the CBA authentication in Power Automate. Over to the demo. Okay, to get started with the demo, let's take a quick look at the credential first. Here's the credential that I'll be using. Just take a look at the credential information. So just to validate that this is for connection, and then we are using it for the Azure Key Vault key store. And then I have the credential type as the certificate-based authentication. And then I have provided the text environment variable called CBA username, and the certificate as the CBA cert name. I want to validate what's values are stored in those two environment variables quickly, right? So here is the CBA username here. If you see, this is the text-based environment variable. Once again, I want to mention one important point. The value for the username has to be in the format of the UPN, meaning user at the domain information. So this is how you need to provide the username value. And for the cert name, it follows the secret environment variable type for secret store KV, the Azure Key Vault. As you can see here, it has all the information that is listed that is needed. The most important thing is the secret name. Here is the certificate name. If you remember, the Azure Key Vault certificate that we have created should be captured here. All right, now let's see how we'll get this started with a Cloudflow that I have created called CF CBA demo, and then it's a very simple one. I'm trying to run a desktop flow, right? I'm trying to run this in this mode. What I'm going to do is I'm going to create a connection. Let's say for the sake of demonstration, I will use the CBA demo, and then use that. And then this is my machine, target machine. Here I'm changing it to credentials, and the credentials that we just looked at is this, right? And then I say new. What it does as it's creating the connection is the actual service is going against the target machine and ensuring that the certificate is valid, and then it is doing the test connection. So once that test connection is successful, you will see that this is showing up as active. We can save this and see if we can run this. All right. The desktop flow that I'm trying to run with this Cloudflow is DF sample flow. Let's run this as attended on the target machine. Okay, so I'm gonna quickly run this through run flow, and this should kickstart the actual flow itself. And here's the machine. Let's wait for it to trigger. The desktop flow is a very simple one. It will just show the message of hello world. There you go, hello from CBA. So as you can see, what we were able to do this here is able to invoke a desktop flow on a machine using certificate-based credentials. Okay, so that concludes the demo. Let's talk about the benefits of using credentials, right? So it actually helps to minimize the operations that you need to manage as part of the RPA operations. With the support of Azure Key Vault and CyberArk CCP, now you have more choices for Credential Store to manage your credentials, right? And in general, with credentials in Power Automate, you will obviously eliminate the need to update any desktop flow connections when a password is changed, right? And with this capability, Power Automate is actually leading the industry in supporting the cybersecurity's modern authentication requirements. I hope you enjoyed this video and learned something about the certificate-based authentication and credentials in Power Automate. Thank you very much, and happy automating.